everyone, welcome to Gemchem. Now today's video is on heterocyclic compounds part 5 video, and here we are going to deal with Hantzsch synthesis of Pyrrole. Now before starting, already 4 videos of heterocyclic compounds are uploaded in channel. You can watch it. I will give the link in the description box as well as the I button present above this video. And if you are new to Gemchem, do not forget to subscribe the channel and hit the bell icon for regular updates. Now let us start. So in this case, the breakage of bond will be same as that of the previous synthesis which we had learnt. So the bond will break from carbon-nitrogen and this carbon-carbon. Finally, the two synthones are like this, and in this case we are going to consider that these carbons will have delta positive charge and the carbon present here will have a delta negative charge. So in order to accommodate these charges, the best substrate having two C plus charges will be your alpha haloketone, and for this one where carbon will have a delta negative charge, we can take as enamine. So in this case, one of the simplest synthesis of this pyrrole can take place using Hantzsch synthesis. We have taken a alpha haloketone, along with that we have taken a alpha ketoester. This alpha ketoester is going to react with NH3 to produce your destined enamine. And this particular substrate on reacting will produce this lone pair present in nitrogen will attack your electron deficient carbon containing the ketone, and we are going to obtain this particular substrate. So here we are going to have NH, here we are going to have the methyl group and CO2 ET. Now from here the alpha haloketone will react with your enamine which is now formed. That is NH2, and here we have methyl group CO2 ET. Now this particular substrate can react with this particular substrate in two different ways. So in the first page we are going to see the first way. So when we take this alpha haloketone, this one, now this double bond attacks. NH2 gives its lone pair. This double bond attacks the ketone portion and this ketone opens up. So what we get is like this. We have this particular framework with methyl Cl. We have double bond NH2 plus, this one is a methyl group. Here we have CO2 ET, here we have O minus, and here we have methyl group. Now what happens is that this particular hydrogen shifts to this oxygen. So finally what we get is instead of O minus and here H2, we obtain this as OH and here only NH. Now this OH will now be protonated. So what we are going to get is this one. We have here Cl, this is your methyl group. We have double bond NH. We have here methyl group, this is CO2 ET, and this is your OH2 plus. This OH2 plus is going to get eliminated by taking up the hydrogen present beside your CO2 ET. So what happens is that this moves out and this hydrogen gives its electrons. There is a double bond formation. So we get here the structure like this. Here we have Cl, here we have your NH, here we have methyl group, this is the double bond, and here also we have a methyl group present. So this one is our methyl group and here is CO2 ET. Now the lone pairs which is present now in the hydrogen is going to get donated in this part and the Cl is going to go outside. So finally what we get is like this. Here we have N and we have H present, and this part we have the methyl groups, and this we have a double bond, and nitrogen will carry a positive charge. This will have a double bond and CO2 ET. Now we will continue in the next page. So this particular substrate which was present there can undergo a rearrangement to form your destined product, that is NH. And you have this one, you have CO2 ET, and you have two methyl groups here. So finally you arrive at the product. Now if the second mechanism is followed, in the second mechanism if you consider, in this case instead of this double bond attacking into the double bond oxygen that is in your ketone carbon, it can attack in the Cl portion. So what will happen in that case? Same product is going to get produced. So in that case you have your substrate as this one, where this is NH2, and you have here CO2 ET. You have another reactant as your alpha haloketone. Now attack takes place. What will happen? This NH2 will donate its electron. Here the attack will take place. So once the attack takes place, the Cl minus will go away. So now the produced intermediate will be like this, NH2 plus, here we have CO2 ET. Now this will undergo some changes to form your double bond oxygen, this one, and you are going to have this as double bond here in this carbon, NH2, methyl group, and CO2 ET. Finally, this will form your destined product. Once this lone pair present in NH2 comes here, this will move out and we are going to get our same product as the previous case. So in two ways you can show the mechanism for Hantzsch synthesis. Both are correct methods, CO2 ET and this one. So one of the important points to note in this case is that synthesis of Pyrrole by Knorr synthesis and Hantzsch synthesis are complementary to each other, and we can obtain the isomeric Pyrrole derivatives using these two. So one of the synthesis we are going to discuss. So when you observe this one, this is alpha bromoketone and this is your enamine formation substrates. These reacts to form this one as your product. So this is your Hantzsch synthesis. But when we shift to another method, that is this one, we provide phthalimide and follow it by hydrolysis, we are going to get such kind of substrate. This one reacting with alpha ketoester, we are going to get our another isomer, which is this one. So you can see the position of the methyl groups has been changed. This is your ethyl 2,5 dimethyl 1H pyrrole 3 carboxylate, whereas this is your ethyl 2,4 dimethyl 1H pyrrole 3 carboxylate. So we can see that isomeric products are being obtained. So this was an important point for Hantzsch synthesis. Now you have to answer a question that during the Hantzsch synthesis of Pyrrole, some furan is formed. So explain its formation using EAA and alpha bromoacetone as substrates. So this much for today. Thank you for watching. Do not forget to like, share, subscribe and comment.